Good afternoon, everyone. Thanks, Amber. So 9 and 10. Okay. All right. So I'll pick up the book. So we look at number 9. Okay. So the question here is the following. Right? A town has a population of 5,000 in the year 2010 and grows at a rate of 6% a year. So every year, that's the growth rate. Let f be the function that to each year assigns the population. Determine a formula for f of t. Okay. So this is a long problem that we've done before. So that's it grows by the same percent. It means that's an exponential growth. Okay, so it's not linear. It doesn't grow by the same amount. So f is a times b to the power t. And t is the number of years after 2010. So t equal to 0 basically coincide with the year 2010. All right, so now what do we have? What they gave us and what we need to find. So we need a formula. It means we need the A and we need the B. So this is one of the problems that we've done before. So here we have A is the initial value, means the value at 0. 0 means the year 2010, because that's what T represents, what's happening after 2010. So this is the 5,000. Now B, I need the growth rate. So the growth rate equal to, now we have to be careful that it is growing, it's not decreasing. So the growth rate is 6%. It means 0.06. So the B is 1 plus the growth rate, 0.06. And the formula will become the initial times the power t. Okay. All right. Now we look at number 10, and then I'll back up to, okay, actually I will do number 8 because the paper is in front of me. Okay, I will read it very carefully. The population of the town is decreasing. So we have a decrease at an annual rate of 3% a year. So it is going down. And let f of t be a times b to the t be the function that to each year assigns the population of the town at time t. Is b bigger than 1 or less than 1? Explain. All right, back to you. What can you say? Right? Anybody will tell me. So we have a population which is decreasing at an annual rate of 3%. So basically, if we're going to graph the function is decreasing. So whatever the function start is going to decrease. So the question is be bigger than 1 or less than 1. The minute we know that the function is decreasing, last time we drew the graph, bigger than 1 increase, less than 1 decrease. So be less than 1 because it's decreasing. But now let us actually compute b, because the population is decreasing. But actually, what's the value of b in this particular problem? It's decreasing at the annual rate of 3%. It means the rate, so we have a negative growth. So the growth rate is actually negative. It's a negative growth rate. Negative 3% means it's minus 0.03. So the b in this case is 1. You take away the 0.03. And you will be left with 0.97. So it's definitely b is less than 1 because we have a negative growth. Right? Okay, so I look at your last question and then we move on. So your last question was number 10. Okay. All right, so here, so it's along the same line. A population, a town has a population of 4,000 in 2010. It decreases at the rate of 5%. And the question is to find the formula for f of t. Okay, I give you 1 minute to give me the formula and put it on bright space. Sorry, put it on chat, all of you, because this is not a hard question by now. I want the formula for number 10. Okay, absolutely correct. All right. Again, this is a scenario where, so number 10. Again, that's a scenario where we have a population and the population is decreasing by the same percent. It means it's not by the same amount. It's not linear. It's definitely an exponential decay. And the initial value, it means it follows the following formula, A, B to the T. A is the population initially. And for us initially is 2010, which is 5,000. Now the B, we have, it's decreasing. So the rate is, we have a negative growth. It's a minus 5%.
Isn't the A 4,000?
Absolutely, yes. Thank you very much. Okay, so it's going to give me minus 0.05. So now I need the B. It's 0.95. It means every year it's 95% of what it was the year before. Because it's losing 5%. So the B is telling me every year it's 95% of what it was. That's where the factor is coming into the picture. So finally, f of t will be 4,000 times the 0.95 to the power t, end of the problem. Okay. Any questions before I move on?
Right. When you wrote the B minus the number, since it's decreasing, do you not write it as 1 minus negative 0.05?
No. Usually the formula is 1 plus the growth rate. All right?
Oh, yeah, I got it.
Got it? Yeah. Okay, any other questions? All right, so today we're going to go back to the logarithm and we're going to talk about the logarithm function. And as I mentioned last time, one of the goals is the logarithm is the following. Suppose you have this problem, that's your population. And it's decreasing, right? It's decreasing. Suppose I'm interested in the following question. So the population here starts at 4,000. And let us say I tell you, okay, when will the population reach 3,000? So I'm asking about the time. When will population 3,000? So I need to solve the following problem. I need to solve that. But here, this is really not an easy problem because the unknown is an exponent. So the question is, how can I solve a problem like this? And the logarithm function that we're going to be talking about its goal is actually to help us deal with those kind of issues. Okay, so the logarithm function, we started it last time and we're going to talk, of course, about it. So the logarithm function. So last time I introduced what we called the log of n. So that's what we did last time. So let us recall. Log of n is, we defined it to be the power of 10, what I should raise 10 to get n back. Okay, so log of n is the number y such that it has the property that if I take 10 to this number, I get n back. Okay, so log n the log of n log. This is a function. You give it a number n as an input, and what's going to give you for output is the exponent of 10. Exponent of 10 that gives n. And very quickly, we kind of played a little bit with this definition. So for example, I asked you, what is the log of 1? What was the answer and why? What's the log of 1 and why? 0, because what's the log of 1? It's the power of 10 that gives me 1. That's really what I am asking for. Which power of 10 gives me 1? It is 0. Okay. And then I gave you something else. I gave you what's the log of 10. Again, I'm asking for the power that gives me 10. Which power of 10 gives me 10 is equal to 1. Okay, so that's really what the log of 10 means. It's what power of 10 will give me the number 10 back. That's really what we are asking for. So if I take log of 100, this is equal to what? Quickly. Okay, please, I want to answer from a lot of students because I did cover that last time and they signed homework over it. So please, you should be able to give me answers. No, the log of 100 is equal to 2. Why? Not 10, it's 2. Because the question is 10 to which power will give you 100? 10 to the power 2 will give you 100 because I'm asking about the power and 100 is 10 squared. So the log of 100 is equal to 2, not equal to 10. All right, so let's do another one. What's the log of 1 over 10? Again, I want answers. Again, the same question. 10 to which power gives you 1 over 10? Again, that's exactly minus 1. Because 1 over 10 is 10 to the power minus 1. That's the definition of 10 to the minus 1. This is 1 over 10. All right. Now, that's a little bit, take a little bit more into this function. Suppose I pick up, as I said, my calculator and I plug in log of 6 and I get a number. What does this number really mean? So I'm going to plug in log 6, and I get 0.778. Okay, what does this mean to us? What's the log 6 mean? Log 6 mean it's the power of 10. It's what I should put here to get 6 back. All right, so in terms of exponent, the log of 6 is the power of 10 that gives me 6 back. So if I take log of any number, log of 7, it means I'm after the power of 10 that gives me 7. It's a very hard question. If I tell you, what should I raise 10 to get 7? For you, it's impossible to answer. That's why the log is really come into the picture. So if I'm getting 0.845, means if I take 10 to the power 0.845, I get a 7. So now let me see if this question makes any sense to you. It may not, but it is all right. Suppose I take 10, number 10, and I raise it to the power log of 6. What do you think I'm going to get back? Anybody have any intuition? So 10 to the log of 6. What should give me back? All right. Somebody is giving me 6. Is this person correct? It's actually 6. Why it is 6? Because that's really the definition. What's the log of 6? The log of 6 by definition is the power of 10, which gives me 6 back. So 10 to the log of 6 equal to 6. This is basically by definition, I mean, that's how it is defined. So by definition of the log, that's really what the definition it is. It's the power of 10 that gives me 6. So based on that, I can keep, if I have 10 to the log 7, this
I have
is,
a question.
yes, please.
So for these ones, we're allowed to use a calculator, but you don't really want us to use a calculator for the previous ones, like the
Right,
easier
right.
ones?
Because here you have to understand, because they are easy.
Okay.
Those, no way, I don't know those answers.
Okay.
That's pure and simple. I don't know them. If I don't know them, no, nobody knows them. No way. Is that clear? All right. That's why it's hard, because how would I know what's the power to give me 7? No way out. That's why people thought about a function. I mean, it took, ages to come up with this idea of this weird function. So it's not trivial, right? So this is again by definition of log. Right? So now this is going to lead me to a first set of properties of the log, which are the following. So first set of properties. Of log. This is the first set. All right. I will ask a question because I've already talked about them. What's the log of 1? Very quickly. This one, no calculator. Equals 0 because 10 to the 0 is 1. Those the one that I want without calculator. I mean, even though I cannot check that, but log of 10 is 1 because 10 to the power 1 equal to 10. Now, what's 10? And this is a little bit more abstract. Should give me what? Exactly. It should give me n back. And that's the definition. That's the part that the hard part, because this is the definition of the log. No more, no less. That's what the definition is. It's the log n is the power of 10 that gives me n back. The last one is the following. Let me remember what I want. What's the log of 10 to the power n? And this is not hard, because this is the log of something is the power that gives me 10 n to the 10. What is log of 10 to the n? Again, it gives me n back. So that's the first property of the log. Okay. Now, so okay. Now we define the thing called the log, okay, of anything of n to be the power of 10 that gives me n back. Now, there is nothing magical about the 10. 10 is I mean, it's a good number because we work with 10 fingers. I mean, that's where the 10 is coming from. That's a decimal number. What we're going to introduce now is the same idea verbatim the same idea. But instead of saying the power of 10, we're going to say the power of another number that we're going to call it the number e. So let me introduce the number e. So the number e. So e is a number in math. It's really like pi. So it's one of those numbers. And the word e is based on one of the most prolific, important mathematicians of all time called Euler's. So the e is reference to Euler. That's where the letter e is coming from. But it's a number. It's a number. It's like pi. It's a number which value is almost 2.718 to 3 decimal places. And then you can find it to more decimal places. So as many decimal as you want. So we can go more decimal, but that's really a value of it. So that's the number e. It's just a number, that's its value. Okay, so it's a number. It's not a variable. It's just an honest to goodness number. So we can talk about, we can introduce, so we can talk about a function f of x equal we can introduce a function, which is e to the x. Okay, which usually is called the exponential function. So e to the x is a function where e is this number and x is the variable. And let us evaluate some value just to make you feel that it is e is a number, no more than that. So that's a x. This is e to the x. So at 0, e to the 0 is 1. At 1, so I can graph here immediately. So that's a function. The input is x, the output is e to the x. That's an exponential function where the b is the e value here. So it's a 1 at 0. It's an e, which is 2 point something. Go like that. If x is 2, this is e squared. E squared, it means 2.7182 squared. So if I plug in this into my calculator, I get a little bit less. It's 7.38. So at 2, I'm right here. At -1, I have e to the -1, which is 1 over e. It means 1 over 2.718. So I can divide this. I get almost 0.36. So it's going to be graph like that. Okay. So that's the exponential function. Basically, that e is a number. It's nothing, not a variable. And we can talk about the function f of x equal e to the x, which is, for those who will do calculus, going to be one of the basic functions you will work with. And that's its graph of f of x equal to e to the x. Now, what are we going to talk about as far as the algorithm, as far as a logarithm is concerned? Okay. So the natural log or the ln. So the natural logarithm. Or sometimes it's called the ln function. All right. So we're going to introduce a function that we're going to call the natural logarithm as follows. All right. Let n be a positive number. Then the natural logarithm of n, or sometimes say of n, which is denoted by ln without log, ln of n is defined by it's the same thing as before, but instead of 10, I'm going to use the number e. So ln of n is the power of e, which is 2.7 something, that gives n back. And back. So it's the same definition as before, but it's the e. In other words, ln of n is the number, is the box, such that if I take e to this box, I get n back. Okay. All right, so let us a little bit practice this definition before we move on. So in mathematically, ln of n equal to y means that e to the y equal to n. So let us practice this the same way we practice the log. So the only difference here is that instead of 10, I have an e. So let us practice it quickly. So evaluate, and please now without a calculator for those values. Evaluate ln of 1. Means definition. I'm looking for something that's at e to the power this, I get 1. So what should go in the box now quickly? What should go? 0. Because e is a number. Which power should I raise it to? To get a 1, you should raise it to the power 0. All right, now let us say again, ln of e equal. As you realize, because what's ln of e? It means e, which is 2.78, to which power I should raise it to get e. That's what ln of e is. So now quickly back to you. Equal to 1, because e to the 1 is equal to e. That's really how we're thinking about it. All right. What is ln of 1 over e? It means e to which power will give me 1 over e minus 1 for the same reason. So it's the same thing as the log, but instead of having for base 10, my base is going to be e. So now I can start playing the game that I played for the log. What's the ln of the square root of e? Sorry, that's in e here. Okay, it means e to which power will give me the square root of e. Okay, square root of e. If you remember, it's e to the power a half. So e to the power a half. So this is equal to a half because e to the power a half was going to give me that. All right, so that's really the definition of the ln. So it's the power of e that gives me the number back in. All right, so now we're going to ask the following question. Again, as I did for the log, I will do for the ln, because I will be working with the ln more than the other log because of its eventually, it will be the function you will work with. So now, again, I'm going to repeat what I did for the log. Suppose I'm computing ln of 6. And now I have to go back to my calculator. What is ln? So this is the ln button. It's different than the log button. This is the log, and that's the ln. So ln of 6 is going to be a different number because it's the power of e. So if I plunge in, I get 1.7917. 1.7917. What does this mean to us? What does the ln of 6 represent? It means if I take e and I raise it to this power, I get 6 back. Okay, so the ln, it means if I take this to this power, I get 6 back. So what's the ln? It's the power of e that's going to give me 6 back. Okay, what is ln of 2? And what does it mean? So if I plug in ln of 2, I get a number, 0.693. What does this mean to us? What does this mean? It means if I take e to this number, I should get 2 back. So that's really what ln of 2. It means what power I should put here to get 2 back. So let me ask you another following question. If I plug in this into my calculator, what should I get? And what? What's e to the ln of 2? Anybody else? What's e of ln of 2? Watch what's e of ln of 2. What is ln of 2? It's the power of e that gives me 2 back. No, this is not e of the ln of 2. ln of 2 is 0.69. I agree. But if I take e to the power that, what should I get back? I get back 2 back. Okay, so that's what the ln of 2 is the 0.693. But what's the property of this number? If I take e to that number, I get 2 back. So if you take basically your calculator and you evaluate e to the power ln of 2, you're going to get 2 back. Because by definition, ln of 2 is the power of e that gives you 2 back. Now I can repeat the same process. E to the ln of 6. What's ln of 6? ln of 6 is the number. When I take e to this power, it will give me 6 back. So this would lead me to the following properties of the ln, of the natural logarithm. So the ln is called the natural logarithm, because that's the one that we work with the most. The first set, because we're going to see 2 sets today. ln of 1 is 0. And this is, we know why, because e to the 0 is 1. The log is the power. ln of e is 1 because e to the power 1 will give me e. Now, what about ln of e to the x? This should give me what? Now I stop. I want an answer. Okay, I'm getting one answer. X is Cindy correct. So what's ln of e to the x? It means e to what power? I get ex. That's what I'm after. That's the definition. Of course, it's x back. So ln of e to the x will give me the x back. The last part is, what if I take e and I raise it to the power ln of x? What I should get? The last one. And this should be based totally on what I did here. E to the ln of x. I take e to the power ln of x. What should I get back? I get back x itself. Why? That's the definition of the ln. Here, there is no reason. That's the definition of the ln. Okay, it's the power of ln of 2 is 2. It's because ln is by definition the power of e that gives me the number back. So let us practice those very quickly. Nothing deep, but just to make sure they are very much drilled in our head. So let's practice that. Okay, the question is simplify, so there will be no ln term in the picture. Suppose I tell you e to the ln of 4. This is equal to what? I don't want ln. What's e to the ln of 4? I want an answer without any ln in the expression, which is going to be 4. E to the ln of 5x. I don't want ln in the answer. Okay, e to the ln of anything will give me this anything back. All right. What's ln of e square? Again, I don't want ln in the picture. And then finally, what's ln of e to the 5x? Okay, what's ln of e square? Without a calculator, if possible. It's absolutely 2. Because when I have ln of e square, I understand it. It means the power of e that gives me e square. Now what's ln of e to the 5x? It's the 5x back. Okay. All right. Now we're going to see another set of property of the logarithm, and slowly we're going to edge toward solving the problems that we are interested in. So another set of properties, so which is an important, but let me take a nice piece of paper. Okay. More properties of the natural log. Okay. So those properties, I will just give them to you. I will not tell you, I will not tell you how they are derived, but we will practice them. So the first property is the following. Suppose I have two numbers, A and B. And then I multiply them, then I take their product. Okay. One of the property of the log is the following. If I take this is equal to the ln of A plus the ln of B. So here I'm assuming A, B positive. Otherwise, the log doesn't make sense. Right? So let us see what does this mean. It means if I have two numbers, multiply them, then I take their log. It's like taking the ln of the first plus the ln of the second. So let's see like a small example. How does it work? So suppose I take ln of 6. Right. 6, I can write it as 2 times 3. It's the product of the two number, 2 times 3. This property is telling me that the ln of that is exactly the same thing as ln of 2 plus the ln of 3. But that's what it's telling me, that if you have a product here, we can split it. So let's verify it at least on a calculator. Let me compute ln of 2 times 3, which is 6. I get 1.79. If I evaluate ln of 2 plus the ln of 3, I get 1.79. So that's really what it's telling me. If I have a product, so both are giving me 1.79. If I have a product inside, then it becomes a sum. Now, a second properties of the log, which is we're going to use the most, is the following. Suppose I have ln of a number, a is positive to a certain power n. The second property tells me that if you have something like this, it's the same thing as n, the power itself, times the log of a. So let's see through an example, what does it mean? So it means it tells me that the following. If I have ln of 2 to the power 3, for example, that's the number I'm finding. This is exactly the same thing as 3, that's the power, times ln of 2. That's the property that we will be using a lot. Okay, so let's check here. ln of 2 to the power 3 means ln 2 to the power 3 is 8. It's the same thing as taking 3 and multiplying it by the ln of 2, 2.07. So that's really what it is telling me. Now, the last properties that the log have is the following. If you take ln and you take a divided by b, the other property of the log is the ln of a of the numerator minus ln of the denominator. It's those properties of the log that make it such an important function. So let us see what this means. It means that if I take ln of 3 over 2, it's the same thing as taking ln of 3 minus the ln of 2. So those are exact same thing. They give me the same answer. So let me, again, we just check on our calculators. Telling me that if I take ln of 3/2, it's the same thing as taking the ln of 3 minus the ln of 2. All right, now let us practice those properties a little bit. So we're going to practice them so they become a second nature to us. All right. So here's my question here. I'm going to put those properties, keep them in front, and I'm going to take a problem where we're only practicing those ideas, no more, no less. So here it is. So practice problem. Suppose you are given the following. You have two numbers a and b, and I know that the log of a, I'm telling you it's a number p. And the log of b, I'm telling you is q. Okay, so we don't know what a and b, but ln of a is a p, ln of b equal q. I can give you numbers, but I don't think we need that necessarily. My question is the following. Use those properties to find. So express the following in terms of p and q. Express in terms of p and q. The goal of this exercise is really to practice those properties carefully. All right. A. If I take ln of a times b, so that's a new number, say a times b. What's this in terms of P and Q? I will do the first one just to tell you what I'm after, and then I will let you the others. Okay, I have ln of A, I have ln of this number, I want to find ln of the product. All right, I use the first property here. Tells me that. This is the same thing as taking ln of A plus ln of B. Okay, that's we're using, if you want to call this one, by the first property. Now, ln of A, you're telling me it's a P plus a Q. So that's ln of AB. So if I know ln of A, I know ln of B, I know ln of the product. All right, now I'm going to give you others, and I want you guys to tell me what the answer is. Suppose I give you ln of A to the power 3. This is equal to what in terms of P and Q? These are the properties that you have to use verbatim to give me the answer. So get going, and please, I want the participation from a lot of you. Whatever you think should be the answer, I don't care whether it's right or wrong. What do you think I am after? No? Keep thinking. Use this correctly. That's really the idea. We want to use this property correctly. So what you are missing in your use. Right. Exactly. So this is going, no, Grace, no. Sorry. Let's use this property. What does this tell you? Let's watch carefully how it works. It tells you, you bring the power down. So my power is 3. You multiply it by the ln of A. That's how it works. It's not to the power. It's 3 multiplied by ln of A. Now, ln of A, I gave it to you to be P. So this is going to be 3P. And of the problem. You multiply it by the ln. You don't raise it to the power 2. Another one. Please, I want more to participate. Suppose I give you ln of A squared over B. And I want this in terms of P and Q. And these are the properties that you have to use. The goal of this exercise is to practice those properties. That's the goal of it. And use it very slowly. And tell me what to write. So the input is the ratio between two numbers. Okay. Can you move the paper over? Which paper, Amanda? This way? Okay. All right. I'm still you still have doing the same mistake, and I'm going to address it again. Okay. There's a mistake that's showing up. Let me go back to ln of A to the power 3. What was the answer? How did I use this? It's n, which is the power. You multiply it by ln of A. You multiply it by it. You don't raise it to the power. So it's 3 multiplied by ln of A. It means 3. The ln of A, I told you, I'm calling it P. It's 3P. So let me do the C, and I'm going to do it very, very slowly. All right, I have A squared over B. So this tells me that you take the ln of the numerator minus the ln of the denominator. I mean, this is ln of A squared minus ln of B. Okay, so it's going to be equal to what? Now, this is the power 2. So this is the power that I bring it down. So it's 2 times ln of A minus ln of B. So watch very carefully. So it's not ln of P. P is the value of the ln. It's the value of the ln. So the answer should be 2. The value of the ln is a P. It's not ln of P. Its value is P minus the Q. So the answer should be 2P minus Q. All right. Okay, I'm going to give you more till you are comfortable. D. Suppose I give you ln of A over B to the power 4. I want this in terms of P and Q. Please, all of you do it. Please do mistakes. Then you will learn it this way. Use the properties verbatim. Okay, anybody else? All right, again, I use the property. You have one over the other. So it's ln of A minus ln of B to the power 4. Okay. Now it is equal to what? ln of A, I keep it, minus. This is the 4. This will go down. So this is going to become 4 multiplied by the ln of B. Okay. Now, if I tell you ln of A is P, you substitute this by P, and you substitute this by Q. If I give you a specific value, you know the specific value. All right, again. What is ln of the square root of A? Again, I want it in terms of P and Q. It's not impossible. It looks weird, but we should be able to nail it down. All right, so anybody else? But I want the answer, Leah. You're on the right track though. Okay, first, what's the square root of A? As you realize, all the property of the log, we don't have square root. It involves something to a power. So to be able to use them, I have really to rewrite this as A to the power. So square root is A to the power a half. So I have to start here to bring the exponent into the picture. So this will give me ln of A to the power a half. Very good. Now, a half is my exponent. So I'm going to use the formula verbatim. I'm going to drop the exponent and I multiply it by the ln of A. And then this finally, this is going to give me a half of P multiplied by P, or if you want, P over 2. So in terms of A, that's going to give me P over 2. Right. Right, so let me give you 2 more. And exercise in the practice, you guys will practice them a little bit more than to be ready for the next piece. So let me give you one more question. A, B, C, D, I don't know which one on it. Suppose I give you ln of A over the cubic root of B. Again, I want you to express it in terms of P and Q. Please, all of you try, not very few. I want all of you. I want different names on chat. Because if you do it, you do mistakes, you learn what you did wrong. When you do them step by step. Do them the way I'm trying to do them. Very slowly, very slowly. Okay. All right, that's nice. Anybody else? Okay, Grace, can you talk?
Yes.
Okay, tell me what you did.
So first I did ln of a minus the 1/3 ln b. I know that it's skipping a step.
You went quickly. You went quickly.
Yeah.
Minus ln of the cubic root of b.
Yeah.
Okay, it's called cubic root. You guys have trouble. Cubic root, fourth root, fifth root. Okay, all right. Now, what did you do?
So I just brought the ln of a down.
Uh-huh.
And then minus the, what is it? The cubic root
Yeah.
of b.
Yeah.
So it would be 1/3.
Yeah.
Sorry.
B.
Yeah.
No problem. B to the third. That's so. She wrote this as B to the third. Keep going.
And then it would be ln of a minus 1/3.
In the power.
Yeah, to the power, and then ln to b.
Yeah, ln of b, not to b.
Yeah.
Ln of b. It's ln of. Now we're done. That's going to give her a p minus 1/3 times q. Okay, so that's how we want you to practice those properties till they become a little bit natural to you. Now, what properties fail? You know, when we're working with log, because it's a hard function, we're very tempted to actually mess up the property. That's why we should basically, all of you should like put those in front of you when we're using them. So I have to address the property that we would like them to work, but they don't. So what properties failed, or what we can't do with the log? With the natural log, with ln, or the natural log. What we cannot do. What we cannot do is the following. If you take two numbers, a and b, you add them, then you take their natural log. So you add them, then you take their natural log. You cannot split that. It means this is not ln of a plus the ln of b. So you cannot split. This one property absolutely fails. What's correct, what we can do if you have a product in between, this will give you ln of a plus ln of b. If you have a sum, you can do nothing about it. If you have a sum inside the parentheses, it will have to stay there. You can't do anything with it. So the only thing we can do, like example, suppose I take ln of 2 plus 3. And then I take ln of 2 plus the ln of 3. And we just plug in those numbers. They are going to be very different from one another. So if I do the first one, it's ln of 5. I'm getting 1.6. If I take the ln of 2 and I add to it the ln of 3, I'm getting 1.79. They are absolutely different from each other. So if I have a sum inside the parentheses, I cannot touch it. It has to stay a sum. We cannot simplify it. We cannot do anything. Now, another thing that we tend, our nature tell us that I should be able to do, but it doesn't, we cannot do, is that when I have ln of a over b, the correct answer is ln of a minus ln of b. So what we cannot do is, this is not, we cannot split it. It's not ln of a over the ln of b. So we cannot really play with the log the way we actually want. We have to be very careful with the properties we use. So if you have a sum, you cannot split. If you have a over b, it's not ln of a over ln of b, because the actual property is the difference. Is ln of a minus the ln of b. So we have to be very careful with the property. Okay. So now the last minute I have before your quiz, I'm going to ask you again, simplification. I wanted to simplify, so the following expression. Okay, I wanted to simplify it, so no ln remain in the expression. So simplify. I'll give you a minute to figure this out. When you shouldn't get it, let me know. 5, okay, Jessica, because. I want to accept answer without a because. Can you talk, Jessica, or not? I don't know.
Yes, I can talk.
Okay, please go ahead.
It's not because like the ln is the same as the e, and like you're.
Yeah, we have to figure it out. And there are
Yeah.
2 ways we can do it.
Oh, because the powers you add on.
Right. If you take e squared times e to the 3, how many e's we have? 2 from here and 3 from here, we add them. It's e to the 5. So this is going to give me ln of e to the 5, which is equal to 5. Okay? All right, so next time we're going to play more a little bit with the ln till we have a good understanding, and then we're going to go back to why we study those functions, how to use them to solve equations. Okay, you guys can go to your quiz, and good luck. If you have questions, you can write on chat privately.